MCP, the USB C for AI tools, one protocol that lets any client talk to any tool without rebuilding the wiring every time. 3 apps on the left, 3 tools on the right. Without a standard, every app has to write a custom integration for every tool. That's N times M. 9 connectors here, 100 in a real org. Everyone rewires everything. MCP collapses the tangle. Every connector morphs into the same shape. Think USB-C. Now apps speak one protocol, tools expose one protocol, and the cost drops from N times M down to N plus M. Build once, reuse everywhere. 3 roles. The host or client, that's Claude Code, your agent, your app. The model lives behind it. The MCP server is a process that wraps one tool. It speaks MCP on one side and the tool's real API on the other. The resource is the actual thing, a database, an API, files on disk. An MCP server exposes 3 things. First, tools. Callable actions the model can invoke. Same shape as the tools from last episode, name, description, JSON schema for arguments. Second, resources. Readable things the client can pull in as context, files, URIs, data blobs. The model doesn't call them, the client reads them and decides whether to attach them. Third, prompts. Reusable templates the server ships that the client can surface to the user, /commands, workflows, scaffolded conversations. The server is a vendor of capability. The client decides how to expose it. Discovery. On startup, the client sends a tools list request, JSON RPC, over the chosen transport. The server replies with a menu of tool descriptors, and the client populates them. Add a tool to the server, restart the client, and it just shows up. That's how MCP servers ship updates without every client redeploying. Transports. This is the load-bearing beat. Get this wrong, and you'll waste a week. Today there are 2 transports that matter, and one that's officially deprecated. Let's go down the list slowly. std.io. The client launches the MCP server as a child process, and they talk over std.in and std.out. No network, no ports, no auth dance. Use it locally, single user, your laptop, file system tools, anything that doesn't need to be reached over a network. Streamable HTTP. One HTTP endpoint that accepts both POST and GET. The server can stream responses back over the same connection. It's stateless, which means it plays nicely with load balancers and serverless. Use it for remote, cloud-hosted MCP services, production deployments, anything multi-tenant. There used to be a third, HTTP plus SSE. 2 separate endpoints, one for POST, one for the server-to-client SSE stream. That got deprecated in MCP Spec 2025-0326 because 2 endpoints didn't play nicely with load balancers or serverless. Major MCP servers have published deadlines. Atlassian Rovo on June 30, 2026, Kabula on April 1, 2026. New implementations should not use this. If you see HTTP plus SSE in a tutorial, that tutorial is older than the current spec. Use streamable HTTP. Secrets. Your MCP config.mcp.json or equivalent references tokens by name, never by value. $curly GitHub token. The client expands those variables in env, args, and headers at launch time, pulling the real value from your environment. The file you commit is safe. The secret stays in your shell. The payoff. One GitHub MCP server. Connect it to Claude Code, to the agent SDK, to your custom app. Same protocol, same tools, same prompts. Write the integration once. Every client gets it. Every client lights up green. This is still one reach at a time. The model asks, the tool answers, done. Loop the reach, and you get an agent. That's the next playlist.